Hi, so in today's video, I'm going to be talking about hydration and hydroboration reactions in Organic Chemistry 1, and I'm going to look into alkenes and alkynes and explain the difference between hydration and hydroboration reactions. So the first thing we have is for alkenes, we have the hydration reaction. So it's the general form of a double bond reacting with water, and as a catalyst you can use H2SO4, and that'll give you an alcohol. Now the question might be, where does the OH go? On the middle carbon or on the one to the right, which is the less substituted carbon? What's going to happen is that this reaction is going to follow the Markovnikov's rule, and we're going to see the OH attacking the more substituted carbon. And one more thing about this reaction is that rearrangements are possible. And one last thing about this reaction is that syn and anti additions are both possible. Okay, so that's pretty much the hydration reaction for alkenes. And the next reaction is hydroboration for alkenes. So we have a general form of an alkene. The first step is that you add the BH3, and that's a separate reaction that happens. And what's going to take place in this reaction is that you have the R. Let's add a carbon here to reduce confusion. We're going to add this BH2 here and here. Now in this case it doesn't really matter, we're just going to have BH2 and H attached, and this reaction is a syn addition, meaning that if there was a stereochemistry involved, these two would be attached from the same side, both from the back or both from the front. So now that's just adding BH3 to an alkene. What happens if we add BH3 and followed by that we add H2O2, hydrogen peroxide, and a base, which in this case we're just going to use OH minus. And also in some cases they use BH3 or 9-BBN, which I'm going to include here. So what's going to happen is that this reaction is going to follow anti-Markovnikov, meaning that the OH is going to attack the less substituted carbon. And in this case, no rearrangements can occur. So no rearrangement is possible. And the final product is a syn addition of H2O, which we're going to see in the later examples in this video. So next we have hydroboration and hydration for alkynes. And what that means is that if we have a triple bond like that, we can have it undergo hydroboration, which is as follows: H2O2, and we'll use a base, in this case OH minus, and we're going to get an aldehyde like that, aldehyde. And then the key to these reactions is that the enolate always forms first, and then it rearranges to a carbonyl group. And the enolate in this case, I'm just going to draw it for you, will look something like this. So this is what the enolate would look like. It's a double bond and an OH attached to it. Next thing, we have the hydration of triple bonds. So we have H2O and then H2SO4 or HgSO4. They usually use all three together, so if you see it in a question, you'll see it all of them together. And then in this case, you're going to get a ketone. And then the enol would look something like this. So you have the OH and then the double bond here. And in this case, this reaction follows the Markovnikov's rule. So that rule is followed, and then the enolate forms first. Okay, so after looking at these questions, we can look at a couple sample questions. One of them that I have here is a hydroboration question. So this one involves a stereochemistry as well. So we have a 6-membered ring with a double bond here, hydrogen, and a CH3, a methyl group. First thing, we're going to attack this thing with BH3, and they usually use THF as a solvent. Any A product solvent would work. And then we still have the ring. So this is going to attack from the same side. So I'm going to draw the hydrogen and the methyl group to the back. It doesn't really matter. You can do it the opposite way. And then I'm having my BH2 and H coming out of the page. And the BH2 attacks the less substituted carbon because it follows anti-Markovnikov rule. And then the next step is to attack it with a base such as OH- and hydrogen peroxide. And you can draw both of these on top of the same arrow. You don't need to show it in 2 different steps. And then retention of configuration happens, nothing changes, and you'll have the methyl and the hydrogen to the back, and the OH and this new hydrogen that attacks to this side. So notice how the OH and the CH3 ended up on the opposite sides to each other. So this one was an example with a stereochemistry involved. The next example that I have, and then before I move on to the next example, let me just tell you that the hydration of this compound would be something similar, but the OH would follow Markovnikov's rule, meaning that the OH would be on the more substituted carbon at the end. And then it could happen both in a syn fashion or an anti fashion, so you wouldn't really have to care about a stereochemistry. And then the next thing we have is a hydration reaction, but for an alkene. Alkyne. So this is the alkyne you have. This is the alkyne you have. A triple bond, and here we go. This is a symmetrical alkyne, so what's going to happen is that when you add H2SO4 and H2O, you're going to get the same product like this. 1, 2, 3 could be on the 3rd carbon, like that. 2, 3, 4, 5, 6. And then here we go. So it doesn't matter where you put the double bond, it's the same ketone, so you're only going to get one product. But in the next reaction, this was a symmetrical alkyne. Then in the next question, we have a non-symmetrical alkyne, which looks like this. Attached. So you're going to add H2SO4 and water to this, and since this is an unsymmetrical alkyne, the product would look something like this. That's when the OH attacks this carbon, or you could also attack the other carbon here. So both are the same. So sorry, they're not the same, so you would get two different products. Here we go. So two products. And honestly, they're both really the same, so you couldn't really differentiate between the minor or major product, and you would have to write both of them down for a reaction such as that. And that's pretty much it. Thank you for listening to this video. Thank you for watching, and bye.